Okay. All right, guys, we are in day 2 of geometry, so things are getting real. Pretty excited to see you guys coming back today. For your do now, I gave you 2 lines, 2 angles. I wanted you to measure those to the nearest 1/16 of an inch using that little kind of cheat sheet, the giant inch. And your angles are just to the nearest degree. So if you guys could, I would love for you guys to just shout out, what are some of the measurements you got for number 1 specific? 1 and, or how many and 3/8? 5 and 3/8 of an inch. Did anyone get something different than 5 and 3/8? We all got that exact answer? What did you get? 5 1/2? Okay, 5 1/2. So everybody got either 5 and 3/8 or 5 1/2. Now those are pretty close. Those are almost the same number. Because if you think about it, 4/8 simplifies to 1/2. So somebody's off by 1/8 of an inch possibly. Let's check. So we're going to get real close on here so we can be as exact as possible. If it'll focus, that'd be nice. Let's see. I'm going to just try to zoom it this way. Yeah, that's smarter. All right. So whenever we are measuring, can somebody remind me, where am I lining up with this edge here of this line? What part of my ruler should be lined up with that? Yes, that very first long line right before the 0 should be right on the outside of that edge of the line. Okay, right there. Now, once you've got that lined up, the tricky part is lining up the other end without moving this. Because what's tough sometimes with rulers is it's like I get this part lined up perfectly, and then when I go to change the other side, it moves. So we got to be really careful and adjust accordingly. So I'm going to put that back where it goes, and I'm going to shift this over and see. Okay. Everybody see where this is landing? I'm going to zoom in even closer. Let me see what I can do here. All right. We're really in here now. So let's mark on our line. This is a good way to make sure we're being as accurate as possible. Which line, by describe it with length, is it one of the shorter lines or the longer lines? Which line is going to tell me where 5 inches is? The longest line that I see, which is right here, the long line right after the 5. This is my 5-inch marker. So I'm going to mark this just to give myself a point to count from. This is 5 inches. Okay. And let's see how many lines I have after 5 inches to count. So I've got 1, 2, 3, 4, 5, 6. Looks like that 6th line is about where the outer edge of this line segment is hitting. Do you guys agree with that, or are you measuring something different by chance? Agree? Okay. So we've got, what do we say, 1, 2, 3, 4, 5, 6 lines. Let's look and see where that would have us falling on our giant inch. Let me zoom out. We're going to look at it together. All right. So if this is our 5-inch marker and we move 6 spaces to the right, correct? We're going to count 6 on here. 1, 2, 3, 4, 5, and 6. Right there. So what fraction is that? 5 and 3/8. Okay, so this is going to be the correct answer. This line segment is 5 3/8 inches. Okay, so if you did not get 5 3/8, do we see now how 5 3/8 is the proper measurement? Okay, awesome. Any questions about number 1? Okay, let's try number 2. So throw some answers at me. What'd you guys get as your measurement for 2? 3 11/16. Anybody get different? You got that? Okay, so 3 11/16. So every person in this room got that exact same measurement? Okay, let's double check it. Okay, let me get to where we don't have a glare. And we'll do the zoom again. Uh-oh, my mouse isn't working. There we go. Okay, so we're gonna have this be our starting point. And do we want our line before 0 to measure up before on the outside of the line or on the inside? Say it again. Before, exactly. We want it to be on the outer edge of the line. If we measure inside the line, we're going to miss part of our segment. So I want to put it right there. Okay, then I'm going to move over, see where this falls. Okay, it looks like we almost have like a half measurement here. You guys see that? How it's falling right in between 2 spaces? So I would probably accept 2 possible answers on this one. I would accept either the tick mark right here or this one, but let's count and see. So here's our 3-inch marker, that longest line right after the 3. And instead of counting all the teeny tiny lines in between, something we could do is we could say the longest line that is right in the middle of 3 and 4, we know that that is our 1/2 inch marker. Does everybody agree with that? Awesome. So I'm going to mark this line and say, okay, so here's where 3 1/2 is. And let's just count from the 1/2. We've got 1, 2, 3 right there. We could go to that 4th line. Let's see what both of those measurements are. The 4th line might almost be too long though. And this is where I would say we might want to do, gosh, even smaller than a 1/16. But since we're going to the nearest 1/16 of an inch, I would accept either one of those lines as your measurement. So let's find out. We start at 3 1/2, we went over 1, 2, 3, or 4. So, oh Lord, come on, zoom. We start at the 1/2 inch and we go over 1, 2, 3, or 4. So in this case, 3 11/16 is absolutely a correct answer. I would also accept 3 3/4 as an answer. Now what am I missing in my answer here? I wrote the number, inch. I got to label my units. So my official answer here would be either one of these, 3 11/16 inches or 3 3/4 inches. Okay. Does anybody have any questions about number 2? Okay, good. How are we feeling? Let's say, give me a thumbs up if you're like, I got this. You could give me a quiz on it today and I would pass. Thumbs in the middle if you're like, thumbs down if you're totally lost. Okay, good. Good. You guys are in a great place then. That's good. I can work with that. Okay, let's move down to the angles. Okay. Somebody remind me, what is this point called? The vertex. Very good. What are we using the vertex for whenever we're measuring an angle? Yes. Perfect. So what Ella said is we need to line the vertex up with this open circle on our protractor. That's going to be our sort of our starting point. So I'm going to take this protractor and line it up right on that vertex. I'm going to be as exact as I possibly can be. And then I want to line up this line here with the bottom line of my angle. Now, what am I doing wrong here? Does anybody see what I'm doing incorrectly?
The other line that starts at 0 isn't lined up.
Yes. So it looks like it's correct right here, but as I follow the bottom line of this angle out, you're going to notice that I actually have my protractor not held correctly. This line needs to be right here at 0. Now, whenever I am measuring an angle that is opening on the right side, am I using the numbers on top to count and measure, or the numbers on the inside here to count and measure? Inside, good. My numbers on the inside start from 0, 10, 20, 30, 40, 50, I'll go all the way up. It wouldn't make sense to count backwards, so we want to use our inner numbers. So let's see where we're passing. It's bigger than 10 degrees. It's bigger than 20 degrees. How much bigger? What measurement did you guys get? 21? 22? Anybody get something different than 21 or 22 degrees? About that? Okay, let's zoom in and be really precise. Let's see. All right, come on. So, we have here, let's go over how to really make sure we're being accurate with a protractor. I'm going to follow this line all the way to the end. So I see here I've got a line going through 20. This 20 lines up with this line right here. You guys see that? So this is 20 degrees. This next line would be 21. This next line would be 22. Okay, so we're still counting upwards since our angle is opening up this way. A mistake that I see some people make is it's like they get confused because the numbers are going in different directions, and they'll see, okay, this is 20, so this is 19, this is 18. Don't do that. Then the angle gets bigger the more it opens up, not smaller. So we want to make sure we're counting in the correct direction. So let me line that back up again. In this case, depending on how it's lined up, because these lines are kind of thick compared to the units of measurements we're given here on our protractor, I would absolutely accept either 21 degrees or 22 degrees since it's a little past 21, not quite to 22. So we're going to label this. You guys remember how to label an angle? Yeah, awesome. Perfect. So what we're going to do to label, as a reminder, is we're going to draw what we're calling a little arc like this inside your angle. And Ella, I love that you mentioned this. You said it's like a little circle, because what we're doing here with an arc is we're just drawing a portion of a circle. If I were to continue this, if I could draw a circle perfectly, I can't, but it would look like this. We're just putting a little portion of a circle here. So you don't need to draw this outer part, just this. And then how many degrees did we say? 21 or 22. I will take either. So 21 degrees, it's that little circle at the top right hand corner, or 22 degrees. And that would be your answer. Any questions on number 3? Okay, let's do the last one. Number 4. We've got a much larger angle here. Mark my starting point here, that vertex at the bottom. And I'm going to tilt mine so that it's a little bit easier to read. Because if I were to just stick my protractor on like this, can I measure my angle this way? Why not? Yeah, it's not lined up with the lines that it needs to be on. If I'm not starting from 0, when I go over to count, my measurement's not going to make any sense. So we want to tilt the protractor until one of the edges is lining up with 0. Doesn't matter which. You could do either way. So I'm going to do it from this side. I'm going to stick that right here. And let's see. Okay, so since we're opening this angle again from the right side, opening towards the left here, am I counting with the outer numbers or the inner numbers? Inner numbers, good. Remember, as we open up, they get bigger. The numbers that are on the inside are increasing in value as we go over. So we pass 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. Are we bigger than 120 or smaller than 120? Smaller, good. We didn't quite get to 120. So let's be real accurate here. I'm going to zoom in again. So it looks like here's 125, or not 125, sorry, 115. We'll keep counting over. 116, 117, 118, 119. Somewhere in between 118 and 119 is the measurement I'm getting. What measurement did you guys get? 119. Awesome, awesome, awesome. So I would accept either 118 or 119. Now, whenever we label this one, because it is a much larger angle, we're going to have a bigger portion of the circle showing here for our arc. So we're going to draw that arc here, and we want to write the angle 118 degrees or 119. Either one I would accept. And there we go. Okay, any questions on these at all? Awesome. Okay, guys, we are going to get into something a little bit different today. So what I would like for you to do is to get out a notebook or paper or whatever you would like to do to keep track of notes in this class. And I'm going to start you on writing some notes today for you guys to have to reference. So in this class, whenever we take notes, I'm always going to be very, what's the word I'm looking for? I almost want to say explicit. I'm going to be very explicit, not in like the bad word way, but in the like being clear way. I'm going to tell you exactly when I want you to write something down, because when I'm telling you that, it's probably something that you're going to see later on a quiz or something. So today, the notes that we're taking, I would write them down if I were you. They're going to be things that are important that you'll want to have to reference later. So if you like to label your notes, I highly recommend labeling just so you can keep track of things and stay organized. This is the start of Unit 1, and Unit 1 is all about measurement, angles, and what we call basic constructions. So we're going to get into some exciting stuff today after we take notes. So I'll give you guys a moment to get that title written down, and then I'm going to give you some vocab words that we're going to be using quite a bit. Okay. So the first vocab word that I'm giving you, pretty simple one, but it's important to know. We need to know what is a line, because we do have a specific definition for a line. Does anybody know what a good definition for line might be? How would you describe a line? Any ideas? I know, it's like the simplest word in the world, just a line. But whenever you really get down to it, it's kind of hard to describe these simple things, you know? You think you know what they mean, but then when you go to try to think of...
It's like you know what they mean, but you don't know how to put it into words.
Yeah, you know what they mean, you just don't know how to put it into words. So I'll help you guys. I'm going to put it into words for you. Basically, a line is... we like to think of it as an endlessly stretching road, okay? It is a long, now I'm thinking of words. Line is hard to describe, guys. You know, it's essentially, let's see. I think I wrote a definition here somewhere. Let me see what I wrote. Line. Well, we're going to describe it with a picture. So a line is something like this. Now, the basic parts of a line that we need to know, what makes a line is the fact that the two directions that it is going, those two opposite directions, they never end. They go on for infinity. So we're going to say goes on in both directions forever. It never ends. So anytime we draw arrows on the end of something, those arrows are indicating to us that it never stops. Arrows are going to tell you that it never stops. It goes on till infinity, which is kind of a difficult concept to imagine, really, because I don't know that we as humans have the capability to truly imagine in our little brains what infinity is. We have no true concept of it because we can't experience infinity until we die, maybe. I don't know what happens after we die. We'll see. So, yeah, I guess nobody really knows. So, a line, it goes on forever and ever in opposite directions, never ends. Now, what we have been measuring is what we call a line segment. Very, very different things here. Line segment. Now, line segment is a little bit easier to describe. We are going to start with a picture, keep it kind of consistent. Basically, instead of arrows on the ends, we could either make points on the ends or do the little tick marks like on your Do Now today. So a line segment does not go on forever and ever. It's just a portion of a line. A line segment has two distinct endpoints. So I'm going to call this line segment a line with two endpoints. And in parentheses I'll say part of a line. And that's how we'll describe a line segment. Okay, once we've got that written down, there's one more term that has to do with lines, and we call this a ray. Has anybody in this room ever heard of a ray, other than like a ray of sun? You have? Awesome. Does anyone know what it is? You don't remember, or you do?
No, I don't remember. I remember learning.
Okay, so at least we've got like a little bit of prior experience. We've heard of it before, maybe we've seen it. I think once I draw it, you'll recognize it. What'd you say? I'll show you. So, a ray is kind of like a mixture of these two.
Oh, is that when one side has like a dotted line and the other one has an arrow?
Yeah, exactly. So the ray has a starting point. There is an end point. But the other end goes on forever and ever and ever. And I like to think of a ray kind of like a sunbeam. There is a starting point. The sun would be that starting point, and the rays coming off of the sun have that starting point, and they shoot off into infinity. They shine on forever and ever and ever. So a ray is just something that has an end point or a starting point, and then the other side goes on for infinity. So I'm going to say has an end point / starting point. I'm going to say other side goes on forever. Okay. So, those are our three sort of line type definitions. All of these come from our original lines. All we're doing different in each of these is choosing whether there's endpoints on both ends, one end, or no end. So, those are our three line definitions. Now what we're doing is we are working with these kind of shapes that we've created to make other shapes. So if you notice, for example, what we just did, we've got line segments and then we've got angles. When we look at an angle, which of these three shapes that we just described, which of these do you think makes up an angle? Which one are you pointing to? The ray, yes. So if you notice on an angle, we have a common starting point and then two rays that are shooting off in different directions forever and ever. An angle is actually made up of two rays. So we're now going to define an angle. And we're going to talk about a few different types of angles and things today. And to define an angle, we're going to say made up of two rays that share a point. And in parentheses by point, I want to define what we call that point when it's on an angle. What did we call this point of the angle?
Vertex.
Vertex. Good. So if you wanted to, you could also, I'm going to label the vertex on the picture I drew, vertex. Maybe I'll circle it. That's the vertex. All right. Now, if you have had any sort of geometry experience in the past, you might remember talking about different types of angles. Do you guys remember any kinds of angles that you learned about?
Obtuse.
Obtuse, acute,
And right.
and right. Yes. Any other triangle types that we learned about maybe? regular or irregular. Yeah, irregular triangles. There's all kinds of triangles or angles, all kinds of things. Now, let's talk about specifically the angles that we're going to be learning about today. Let me get my notes and make sure I show you the right ones. So, I think today we are going to be talking about the angles that Ella just mentioned, actually. So here we're going to make a little section of angles. I'm going to call this types of angles. And we are going to use our protractors to draw these angles in our notes. We want to be really accurate with our representation. So, first angle we're going to do is what we call an acute angle. Acute angle. So, I am going to write here acute angle. And under acute angle, we're going to give ourselves a starting point. Let's see. Actually, I'm going to trace a line first and then do a starting point. Okay. So once you've drawn a line, I'm going to give you guys a second. I want you to draw a nice straight line under acute angle. And then you can pick which either side, I don't mind, that you want to open your angle from. Whichever end of your segment that you've drawn here, you want to line up your circle on your protractor with one of the ends, just like this. Okay. Now, the definition of an acute angle is any angle that is less than 90 degrees. So if you remember, or if you just look at your protractor, an angle that is 90 degrees goes straight up and down. It's going to create that right angle. So an acute angle is just any angle that is smaller than that. So you can choose any of these to be your angle. I'm going to go with like 40 degrees. So to make a 40-degree angle, what I'll do is I will find 40 on my protractor and I'll make a little mark right here under it. See, I just made a little dot. And then I'm just going to connect that dot to my end point that I measured from. Can you guys see that okay? It's really tiny. Let me make that dot bigger. There's my dot. So I'm going to line it up. Just like that. And I'm going to put a little arc on it. Now, whenever we are drawing angles, we always want to put arrows on the end to show that they go on forever. And then I'm going to put a little point where my vertex is. So we can also double check that our angle is about what we wanted it to be. So I wanted mine to be about 40 degrees. Looks like it's falling right about on 40 degrees. Yours could be 50, could be 60, 70, 80, could be all the way up to 89. Just cannot be 90. Could be all the way down to 1, whatever you like. Yes? Do you want me to walk through how we made the angle again? Yeah, so what I did is I just started by drawing a straight line from left to right here. Then I just chose to start with this point on the left side. So I lined my protractor up with that point there. See this? So that's my point. Then I decided to open it this way, and I said I want mine to be about 40 degrees. So I found the 40 on my protractor, and I just marked a little point right under it, right there. You see that? So then when I took my protractor away, I didn't have this line yet. I just had this point, this line or this ray, and this point. So to make the other ray, to have the angle, I just connected that first starting point with the new point that I made, like that. Just traced that there. I appreciate you asking, really. If any of you at any point missed something, you know, I get it. Sometimes you're paying attention and you're trying to write and stay caught up at the same time, and then you miss a little bit of the instruction. Let me know so I can repeat it and get you where you need to be. I do appreciate that. So, did everybody get some sort of angle smaller than 90 degrees drawn? Awesome. So, under acute angle, I really want to make sure that I define this, because just drawing this picture, I might go back and I'm going to not remember that it means an angle less than 90. I want to put in here any angle that measures less than 90 degrees. That is what an acute angle is. And a good way to remember that the acute angle is the small one is just by thinking about the way the name sounds. It's an acute angle. It is so cute and little. It's tiny. It's the smallest angle that we have. So acute angles are the ones that are less than 90 degrees. Okay, are we ready for the next type of angle?
No, not yet.
Okay, take your time. All right, so the next type of angle we're going to talk about today is what we call a right angle. So we're going to make another one, right angle. Does anybody already know what a right angle is? Yeah, it's just an angle that is exactly 90 degrees.
Which is basically like each side angle working.
Exactly. So right angles, you see them everywhere. Any piece of paper, all the corners are right angles. Most tables are ending at right angles. Door frames, walls. There are lots of right angles in this world.
Isn't it confusing when tables look curved? And
Yes.
then
Yes, it is. So our tables in this room, if they did not round off the vertex or the vertices of the ends of the table, it would be a 90-degree angle. But since they're rounded, it's, I don't know how I would describe that. But if we were to extend the edges and make it sharp and pointy, it would be a 90-degree angle. So let's construct a 90-degree angle. What I am going to do is start, and it might be a little easier if we begin this one a little lower, because if I were to start it at the same height, you absolutely could still, bless you, you could still do it from here, but whenever I try to mark my line for 90 here, you're going to see I'm running into my words. So I'm going to bring mine down just a little bit. And I'm just going to draw a line straight across, left to right. It does not matter how long or short it is, just need a line. And let's go ahead and decide which part is going to be our end point and which part is going to be our arrow, so that we have a ray. And you don't have to do it the same direction as me, but I'm going to have mine pointing to the right, opening up from the right side to the left. So now that I've got a ray drawn, what I need to do is line up this little circle with the end point of my ray, like this. Okay, and we want to find 90 on our protractors, and that's going to be just right here. So I'm going to mark, see where I am, right under the 90 here, so that I can be as accurate as possible. The other thing you could do is these protractors have little dots right on the 90 where you could just take your pen or pencil and just stick it through that hole. You see that? You could totally do that. Or you could draw a little line right there. Once you've done that, we're just going to connect the dots. We're going to start with that starting point that we created on our ray, and we are going to connect to those new points that we created. And we should get pretty close to a nice 90-degree angle. So whenever we are labeling a right angle, we do it a little bit differently. We don't actually draw an arc in it. Anybody know what we draw in a right angle? Yeah, like a little part of a box, a little square, exactly. Whenever we have a right angle, we want to show a little box inside. So if you ever see that box, you can automatically know that this measures 90 degrees every time. So to define a right angle, it is an angle that measures exactly 90 degrees. If it is 91 degrees, it is not a right angle. If it is 89 degrees, it is not a right angle. If it is 90.0001 degrees, it is not a right angle. It has to be exactly 90 degrees. And if you notice, I can take a piece of paper and it should line up with that right angle pretty perfectly. Yeah, that's pretty darn close.
May not be perfect.
Yeah, may not be perfect. And I'll tell you what, it probably is not going to be perfect because I am definitely not a perfect drawer.
Sorry, I talked my letters and like 3 times.
And that's all right. Okay, there is one more type of angle we're going to talk about. Does anybody need more time to copy this down? Or are we ready to move on? Okay, you just say the word if you need me to wait. I'm happy to. Okay, the last kind of angle we have is an obtuse angle. O-B-T-U-S-E. So we have two types of angles so far. We've got one that is 90, one that's less than 90. What do you think our last type of angle is going to be?
Over 90.
More than 90. Yeah, exactly. So let's go ahead and start constructing an angle that is bigger than 90 degrees. I am going to draw a ray first. And I'm kind of in the habit of making them open in that same direction, but again, you can make it different if you like. Now, I think I might have, no, it'll still work.
It's weird.
It is a little odd, isn't it?
Not just that. You know how, like, since the paper is thin,
Yeah.
sometimes when you draw, since it already did some of the favorite tampers when you're drawing again.
Yeah. Oh,
That's,
did it mess with your notes?
no, it's just boring. That's a couple books.
Oh, I gotcha. I hate when it does that.
Painted already.
Right. Okay, so does everybody have at least a ray drawn? Perfect. So we're going to do the same thing. Line your protractor up with that circle on your end point. And we're going to follow our numbers on the inside or the outside? Inside, very good. So here's 90 degrees. We need to go bigger than 90 degrees. So we can do any of the numbers this way. Doesn't matter which one. I'm going to do 130. Because why not? So there is my connecting point. And I am going to just take the edge of that protractor, line it up with the end point with my new spot, and I'm going to draw the other ray. Just like that. There is my obtuse angle. I'm going to put a little arc inside. And then we want to define it as any angle that measures more than 90 degrees. And again, at any point, if you need me to stop, go back, re-explain, you just let me know. I won't ever be frustrated with anybody. So any angle that measures more than 90 degrees. Perfect. Perfect, perfect. Okay. So once you've got this all written down, we're going to do a little bit of practice identifying these angle types. So, does anybody still need this, or are we all caught up? Okay, looks like we're all caught up. That's good. So, to do some practice, what I am going to have you do is I'm going to give you a list of angle measurements, and I want you to create those angles from your protractor, starting with a line or a ray, and then finding the correct number on that protractor, marking the point, drawing the other ray to that correct degree. So the first one, I want you to make a 30-degree angle. And then I want you to tell me what type of angle it is. Is it acute, right, or obtuse? Number 2, I want you to do a 50-degree angle. I'm going to give you about 5 of these. 89-degree angle. And I'll set a little timer, and I want you guys to try these on your own for a minute. Now, number 5, I'm giving you a tricky one that might throw you for a loop. So if you get to number 5 and you get stuck, that's okay. I want you to at least attempt it though. So remember, each of these I want you to draw the angle and label with the correct type of angle.
So like if it's a right triangle, acute
Yes, yes. So I want you to tell me, is it an acute angle, a right angle, or an obtuse angle? And number 5, because it is a different one, I want you to kind of do some discovery, see if you can figure out how to draw this. I'm going to tell you it's not going to perfectly fall into one of those categories we just talked about, so don't get too stressed trying to figure out what kind of angle number 5 is. I just want you to attempt drawing it and see what happens.
That's a full straight line, Lois.
Work on it, we'll see. You're correct, though. Absolutely. Okay, let me pause this, and I'm going to set a little timer for you guys. Okay, so I was walking around the room kind of looking at your angles, and it looks like you guys are definitely on the right track. I think y'all are doing it excellently. So first, let's talk about what types of angles these are before drawing them. 30-degree angle, what type is that? Acute, very good. That is an acute angle. And if you ever want to abbreviate the word angle, see I wrote it out so many times, this is our abbreviation. We just draw a little baby angle next to it. So you can always do that to label.
So pretty much the crocodile mouth that you used to know number bigger or smaller.
Right, right. And number 2, 50-degree angle, what kind is that? Also acute, very good. And 89-degree angle, what's that? Also acute. Almost a right angle, but it's not. Acute. Okay, how about number 4? What is this? Obtuse, very good. It is larger than 90. And finally, number 5. This one's a little weird. 180-degree angle. Before we talk about what type it is, let's talk about what that looks like. What does your 180-degree angle look like? Yup, yup, yup. If you did it correctly, and I'm going to go through drawing it to make sure that we did, you should have a straight line. A straight line. We call this a straight angle. Straight angle because it makes a straight line. So whenever we are drawing a 180-degree angle, here's what I'm going to do. I'm going to put, actually I'm going to do it like right under it. Here is my starting point right here in the middle. And my first ray is going to go all the way over here to 0. There's my starting point. So I'm going to trace this line, trace this ray. And when I line my protractor back up, here's what we're going to notice. Okay, let's get that perfect. So if I'm opening from this side, am I looking at the numbers on the inside or the outside again? Inside. I got 10, 20, 30, 40, I'm up to 90. Keep going over, keep going over. I see that here's 170. So I'm going to follow this line to that outer edge, and let's count and make sure that we've got all the way up to 180. So we've got 171, 2, 3, 4, 5, 176, 7, 8, 9, 180, right on that bottom line here. So I can mark that on the outside, and when I connect my ray to my new point that I made, I hope I can get this just right. It's kind of tough tracing these lines because exactly like what you were saying earlier, wherever you put it, it's like your line wants to be just a little bit off from the point that you've got your straight edge lined up on. So mine's not perfect.
That's why I just did mine in a straight.
Right, that's probably the smartest way to do it. Your straight angle looks like this. 180 degrees. Now, let's draw the arc on it. You're going to notice that it looks like half of what? A circle. We made just half of a circle here. So guys, if half of a circle is 180 degrees, how many degrees do you think is a whole circle all the way around? 360. If I add 180 plus 180, so if I did another turn and went all the way back around, I'm going to get that full circle, and that full circle is 360 degrees. Just like that. Nice. What were you saying, Ella? I think I interrupted you.
Most things, when they ask for something that there's not really something to that because it's around this.
Yeah.
Constantly goes in.
That's
and
right.
It actually creates an angle.
So here's how we would show the angle that creates a circle. I'll show you that to kind of go along with what you're saying. If we wanted to show an angle that is 360 degrees, it would look a little funny actually. It's going to look just like this. You're just going to draw your ray. And actually that's it, because your starting point, you're going all the way around, it's going to line up with your ending point. So to label this angle as 360 degrees, we would just draw that whole circle to show that it went all the way around. There is 360 degrees angle. That's your circle there. Kind of interesting. Kind of interesting. So that's going to be our circle there. And that's our straight angle. All right. So guys, I think that's going to be all that we introduced today. And it is 10:24, 1 minute till we leave. I'm going to give you a break today. No exit ticket. We've been going through a lot of stuff, and to be honest, me as a teacher, I need to get a good plan going for what we're going to do moving forward, because you guys are getting this, I feel like, and that is wonderful. So today, no exit ticket. Those do nows that you did at the beginning of class, I've seen that you've done them. Those are just for participation. Keep them in your notes if you like. Remember, over here, I have all your names on these folders and these bins. You guys are period 1. If you want to keep any of your notes in your folders, feel free. If not, you're welcome to hold on to them yourself. But again, that is all today. No exit ticket. You all are free to go. And I'm going to end that recording.